야, 나는 드디어 말하면
Good evening, students. Am I audible?
Yes, sir.
Just a minute. Yeah. So yesterday the topic that we were discussing is electromagnetic waves, right? So is there any doubt from yesterday's class that you have? Any concept that you want me to repeat? Nothing? So everything is clear from yesterday's class. Is there any topic? I asked you guys to revise it. Is there any topic that you want me to explain again? Clear?
Yes, sir.
Yes, sir.
So I think what was the last point that we have seen? We have seen till C is equal to E by B, right? Now, the next concept that we are going to see is what is the energy of an electromagnetic wave? Okay. So we know the fact that electromagnetic waves, see, generally wave itself is a disturbance that carries energy from one point to another. That is the main objective of a wave, right? So what do we mean by energy of an electromagnetic wave? As we know that they are going to propagate, they carry energy along with them. But how is that energy getting carried? The energy is going to get carried in the form of the energy is going to get so the energy is going to get carried in the form of electric field and magnetic field. Right. So when the electromagnetic waves are propagated, then the energy in the electromagnetic wave is partly carried by the electric field and partly carried by the magnetic field. Now, if we have to look at it mathematically, then the total energy that the electromagnetic wave possesses is due to whom? A part of the electric field and a part of the magnetic field. So, the total energy stored per unit volume, though the concept is energy, we are going to calculate the energy stored per unit volume. What do we call this as? The energy stored per unit volume is generally called as energy density. So we are going to calculate the energy density that is associated with an electromagnetic wave. So how are we going to calculate? Let's see. So can I say that the total energy associated with the electromagnetic wave is due to the electric field partially is due to the electric field plus the magnetic field, right? So this is the energy per unit volume. What is the energy density of electric field? Do you guys remember this formula? Half epsilon naught E square, right? Similarly, the energy density of magnetic field is given as B square divided by 2 mu naught. So half epsilon naught E square is the energy density due to the electric field, and B square divided by 2 mu naught is the energy density due to the magnetic field. So let this be equation number 1. Now the next thing is, we know that C is equal to E divided by B, and C is also equal to 1 divided by root of mu naught into epsilon naught. Okay. Now what I'm going to do is, I'll take this epsilon naught E square, where I will write epsilon naught in terms of mu naught and E in terms of B. So how can I do that? I can write E is equal to C into B. Let me call this as 2. Similarly, can I write epsilon naught is equal to 1 by mu naught into C square. I'll call this as 3. Now I will use 2 and 3 in 1. When I use this, I'll get half into epsilon naught is 1 divided by mu naught into C square into electric field is CB. So I'll get C square into B square. So C square and C square will get cancelled plus 1 by 2 into B square divided by mu. So what will be the answer? B square divided by 2 mu naught plus B square divided by 2 mu naught is going to be the answer. Right. So that will give us B square divided by mu. Clear? So this is going to be the total energy possessed by the total energy per unit volume possessed by the electromagnetic wave. In a similar way, if you write mu naught in terms of epsilon naught and if you write B in terms of E and substitute it in the place of B square divided by 2 mu naught, you will get the total energy as half epsilon naught E square. Okay. So, sorry, not half epsilon naught E square, it is only epsilon naught E square. Okay. So, this is what happens. This is the total energy per unit volume that is possessed by an electromagnetic wave. Please make a note of this. Write it down. Okay. You're able to understand? Okay. These two are the formulae for the total energy. Okay. Now, based on this, we are going to see certain properties that are associated with respect to an electromagnetic wave. That is the next concept. So, properties. The next heading is properties of electromagnetic waves. So, if you talk about the velocity of electromagnetic waves in space or vacuum, it is a fundamental constant and its value is given as 3 into 10 power 8 meter per second. Okay. Secondly, we do not require any material medium for the propagation of electromagnetic waves. They are obviously non-mechanical waves, but it doesn't mean they cannot propagate through a medium. They can do as well. They can propagate through a medium as well. Okay. Lastly, EM waves carry energy and momentum, and the energy per unit volume associated with it is epsilon naught E square. Okay. So these are the properties that are related to electromagnetic waves. Are you guys there?
Yes, sir.
So is it clear? Is there any doubt that you have?
No, sir.
The next concept is
Sir, 1 second, can you scroll up?
sure. Yeah.
Okay, sir. Thank you.
Listen. So the last one is we know that electromagnetic waves carry energy. We should also know the fact that electromagnetic waves have the tendency to exert pressure. So what basically comes to our mind when we speak about pressure? Pressure is the amount of force per unit area. But what is force? It is the rate of change of linear momentum with respect to time divided by A is area of cross section, right? So if there is an object where there is a change in momentum taking place for that object, we can say it has the tendency to experience force. If that force is acting per unit area, then we can say it exerts pressure. We see, for example, sunlight falls on us. Do we ever feel the pressure of it? So sunlight keeps falling on us. Do we ever find the pressure exerted by it? The answer is no. We never feel the pressure. But we know the fact that sunlight is an electromagnetic wave. Light is an electromagnetic wave, and that electromagnetic wave is able to carry some momentum and energy associated with it. When that is happening, it should be able to exert pressure. But why are we not able to feel? That's what we are going to see. Okay. So the explanation is, as electromagnetic waves carry energy and momentum, they exert pressure. And the pressure exerted by the electromagnetic waves can also be called as the radiation pressure. That is the first point you need to make a note of. Okay, make a note of that point. Okay, now listen. Example is sunlight. So sunlight which comes from sun is a form of visible light rays which are also a part of electromagnetic waves. So generally what happens if we keep our palm in sun for some time, what happens? The palm becomes warm and it starts sweating. Right? This is a known fact. Right? So listen. So why is this happening? This is happening because sunlight is getting transferred in the form of electromagnetic waves, and the electromagnetic waves carry energy. Means the heat is getting generated, due to which the sweating is happening. Right. So what is going to be the momentum with which it is going to exert a force on us? Okay. See, suppose the total energy transferred to the hand, if I take it as E, then the momentum that is associated with the electromagnetic wave is given as E divided by C, where C is the speed of the light. Right? So what is momentum? Momentum is given as E divided by C. This is a dimensionally derived quantity. But we know the fact that C is 3 into 10 power 8, which is a very, very large quantity. So when this quantity is going to be large, what is going to be the value of linear momentum? Will it be large or less? When the value of speed of light is maximum, what will happen to the momentum? So since they both are inversely proportional to each other, momentum will decrease. So momentum is less, hence the pressure experienced is also less. This is the reason why we do not feel the pressure of sunlight on our hand. Okay, it is because the speed of the light is more. Okay, so this is all about the mathematical expressions that are related to this particular chapter. Okay, so the next part, shall I move on? Is there any doubt you want to get clarified? Okay, I'm assuming there is no doubt. So the next part that you're supposed to understand is the concept of electromagnetic spectrum. So there is a concept of electromagnetic spectrum that is there. You guys know what is that spectrum. So it is actually a data sheet which is categorized based on the frequency and the wavelength of a particular electromagnetic wave. Means that the whole electromagnetic waves are divided into different parts like long radio waves, AM radio, television and FM radio, short radio waves, microwaves, infrared, visible light, ultraviolet, X-rays and gamma rays. All these things are segregated based on the frequency. They have a particular bandwidth associated. See, for example, X-rays lie within this range of frequency. Ultraviolet rays lie between this range of frequency. So, you're able to understand? So, this is a data sheet where the frequency increases in this direction and wavelength increases in the downward direction. Okay. So I hope you would have already seen this in your chemistry, electromagnetic spectrum. So with respect to physics and exam point of view, what you need to understand from this particular topic is the different kinds of electromagnetic waves that are there. Okay. So the different kinds of electromagnetic waves that are there are, see, these are the topics: radio waves, microwaves, infrared waves, visible rays, all these things are there, no X-rays, gamma rays, and all those things. So for this, what we will be doing is, it is only 2 pages. Listen. So the type of question that they will ask in your exam is, see, suppose you take a radio wave. Can you tell me where are, can you tell me where are radio waves useful? Where do we apply the radio waves? It is mainly used in the process of communication. Okay. Listen to this carefully. The questions that they will be asked is the possible questions that are there in this chapter are, they can ask you what is the source of a radio wave, or they will say that there is a charged particle which is vibrating in this kind of a fashion. What kind of a wave will get generated? Something like this. Okay. See, for example, radio waves are produced due to, we know the fact that radio wave is an electromagnetic wave. What is the source of an electromagnetic wave? It is an accelerated charged particle. Right. So when it comes to accelerated charged particle, different charged particles can be put into different kinds of vibrations to generate those waves. See, for example, radio waves, if you take, they are produced by the accelerated motion of charges in a conducting wire. So the question that they can ask is, name the electromagnetic wave that is generated due to the accelerated motion of charged particles in a conducting wire. So your answer should be radio waves. Okay. Sometimes they'll put a question like this. Name the electromagnetic wave which is used in communication. The answer is radio waves. Okay. So they are used in radio and television communication systems. So what I want to say here is, all these things are completely theoretical, where I have nothing to teach. Okay. But I'm going to give you an outline of what you're supposed to do with these 2 pages. So that will be a part of the homework and you have to work accordingly. So you take the notes in this way: radio waves. Okay. First, you will write it as source. So what is the source of accelerated charged particles in conducting wire? Okay. Secondly, uses. So it is mainly used in radio and television communication. Okay. Third, frequency range. So what I'm trying to do is, I'm trying to break each sentence into each point. They're generally in the frequency. So frequency range is 500 kilohertz to 1000 megahertz. Okay. In a similar way, you have to prepare a table for all these things. Actually, they themselves have given you a consolidated table here. So questions will be based on this point. So you're able to understand. So this is the only topic I generally give it as self-study because there is nothing to teach from my end. Okay. So this topic alone, you guys read it. I will be doing some problems from all the topics that we have discussed. Okay. By the way, we are at the end of this chapter. We are about to complete this. There is only one subtopic that is pending, that is displacement current. Okay. Listen. So let's do example 8.2. There is a plane electromagnetic wave of frequency 25 megahertz. So what is the value? Frequency is 25 megahertz. It is traveling in a free space along the x direction. At a particular point in space and time, the value of electric field as a vector is given as 6.3 J cap volt per meter. B vector is equal to how much? How to solve this? You already have a formula. How to do, guys? There is a simple formula that gives you the relation between electric field and magnetic field. Guys, are you there or not?
Yes.
Why are you not answering? What is it? I asked you a simple question. Electric field is given, you are asked to calculate the magnetic field. How will you do?
Use that C equal to E by B formula.
So you know that C is equal to E divided by B. So B is equal to E divided by C. So E is 6.3 divided by C is 3 into 10 power 8. So you'll get 2.1 into 10 power minus 8 hertz. Sorry, not hertz, Tesla. 2.1 into 10 power minus 8 Tesla. Okay. Next problem.
Sir, then what happens to J cap, sir?
Okay, I have to tell that. So electric field is equal to 6.3 J cap. 1 minute. Wait. Now see, 2.8 into 10 power minus 8 Tesla is there, right? Now, with respect to an electromagnetic wave is what? So electromagnetic wave is a transverse wave. So what do we mean by transverse wave? Electric field and magnetic field are mutually perpendicular to each other and they're perpendicular to the direction. So the wave is traveling along x direction. Electric field is along J cap. Then what will be the direction of magnetic field?
It will be perpendicular.
So it will be in the direction of K cap. So yesterday I explained, no? If electric field is in y direction, propagation is in x direction, magnetic field should be perpendicular to both. The one which is perpendicular to both is z direction. That's it.
Okay, sir.
Okay. The next concept is The magnetic field in a plane electromagnetic wave is given as Dy is equal to 2 into 10 power minus 7 sine of 0.5 into 10 power 3x plus 1.5 into 10 power 11 t Tesla. Okay. Now, what are we supposed to do? What is the wavelength and frequency of the wave? So, if I compare this with By is equal to B naught sine of kx plus omega t, then how much is the value of k? 0.5 into 10 power 3. So, what is k? It's 2 pi by lambda is equal to 0.5 into 10 power 3. So, lambda will be equal to how much? 4 pi into 10 power minus 3. So, it is 12.42 into 10 power minus 3, which is also equal to 1.24 into 10 power minus 2 or 1.24 centimeter. Is it clear? So that is the wavelength. Now what did they ask? They asked the frequency. How do you find the frequency? Omega is there. So omega is equal to 2 pi f. So 2 pi f is equal to 1.5 into 10 power 11. Correct? So what will f be equal to? 1.5 into 10 power 11 divided by 2 pi. So these many hertz will be the answer. So it's 1.5 into 10 power 11 divided by 2 pi hertz. Next is we need to write the equation of electric field. Now tell me one thing. The wave is propagating along x direction. Magnetic field is along y direction. Then what will be the direction of electric field? Propagation is along x direction. Magnetic field is along y direction. Then what will be the direction of electric field? It means z direction.
Z
Correct?
direction.
So Ez will be equal to E naught into sine of kx plus omega t. E naught into sine of kx plus omega t. What is the value of E naught? E naught is C times B naught into sine of kx plus omega t. Okay. So what is the value of C? 3 into 10 power 8 into what is the value of B naught? B naught, how much is it, guys? 2 into 10 power minus 7, correct? So 2 into 10 power minus 7 into sine of kx plus omega t. I will write the same thing, sine of this thing, 0.5 into 10 power 3x plus 1.5 into 10 power 11 t is going to be the same thing. So 3 into 10 power minus 8 into 2 into 10 power minus 7 is 60. 60 into sine of 0.5x into 10 power 3x plus 1.5 into 10 power 11 t. These many volt per meter is going to be the answer. Okay.
Yes, sir.
Light with an energy flux of 18 watt per centimeter square falls on a non-reflecting surface. So there is a non-reflecting surface. Light is falling on it. So how is it falling? So light is falling on it at normal incidence. Means light is falling in this way. Okay. And this energy flux actually means energy density, or I can say energy flux actually means intensity of light. Okay. So if you guys don't know what is intensity of light, please write it down. Intensity is the amount of power radiated per unit area. So amount of power per unit area is what we call it as intensity. If you observe, what is the measure of power and centimeter square is a measure of area. Okay. So it is falling on the surface which has an area of 20 centimeters square. Now our job is to find the average force exerted on the surface during a time span of 30 minutes. So light is continuously falling on that surface and it is getting absorbed because it's a non-reflecting surface. Our job is to find what is the total force exerted by the light for the span of 30 minutes time. Okay, now see. So for that, what I'm going to do is I know that force is equal to momentum by time. So momentum is equal to energy by speed. So total energy will be equal to intensity into area into time. Okay. So what is the intensity? What is the intensity? It is 18 watt per centimeter square into area is 20 centimeters square. So you need not convert centimeter to meter. So 18 into 20 into time is given in terms of minutes. So 30 minutes into 60 seconds. So how much will be the answer? It will be 6.48 into 10 power 5 joule. If not wrong, you will get 18 into 36. 18 into 36 is going to give you 6.48. Okay, it's actually 324 into 2. 18 square is 324 into 2 is 648. So 6.48 into 10 power 5. And momentum will be how much? 6.48 into 10 power 5 divided by what is going to be the speed? It is 3 into 10 power 8. Okay, it is 2.16. So it is 2.16 into 10 power minus 3 kilogram meter per second. This is the momentum. So what is going to be the force? Force is momentum by time, that is 2.16 into 10 power minus 3 divided by the time is how much? 30 minutes. So 30 into 60 seconds. If you solve this, you will get the answer as 1.2 into 10 power minus 6 Newton, which is a very, very, very small value. Okay. It's 1.26 into 10 power minus 5. I think 1.10 power minus 6. To 10 power minus 6. Okay. So this problem is not needed. Okay. So last concept that is left out in this chapter is this concept of displacement, which I will explain in the next class. This is the only topic that is left out. Once displacement current is over, I will start chapter 9. So tomorrow I'll be starting chapter 9, which is also called as ray optics. So the base for ray optics is going to be this chapter. Apart from this, is there any other doubt that you guys have? Is there any other doubt or anything else you want me to explain again?
No, sir.
Everything is clear? So as I told you, this part alone, please do a self-study. And if you have doubts, bring it to me. Okay. So displacement current maximum of 15 to 20 minutes time, but that's a fresh topic. So I want to take it tomorrow so that you're not confused between this one and the other things. Okay. So once that is over, I think we are good to start the next chapter. Next chapter is an interesting one. We will see. Okay. Any other doubts? So there are no doubts, then I think we can wind up.
Thank you.
Thank you.
Thank you, sir.
Thank you, sir.